Okay, well, I think we'll make a start if that's okay. Alex?
Sure.
Wonderful. Welcome everyone to IE University's Masterclass today. My name is Sheena Mehta and I lead IE's international office in London. As most of you know, IE is an international university which is based in Spain. We offer undergraduate degrees, master's programs, MBAs, executive education, and custom programs for companies. We're made up of 5 schools, including IE Business School, IE Law School, IE School of Human Science and Technology, IE School of Global and Public Affairs, and IE School of Architecture and Design. Now, IE's London office team had been running a series of fortnightly masterclass events up until we had to limit our movements and our social gatherings. And this session on space tech was scheduled to take place 2 or 3 weeks ago. But of course we had to cancel, but we were, however, able to move this class to an online format, which has meant that many of you, even more of you, have been able to connect to it, and we're very excited about that. Just so you all know, we have invited potential candidates who are considering our university for higher education. We have invited IE alumni to continuously learn with us, and anyone who is interested in the topic today. However, we want this to be quite an interactive session. So you will see that you have the opportunity at the bottom of the screen to include your questions to Alex. So although the chat is disabled, the question and answer facility is available. Please input your questions there. And if you see questions that you like or questions that you would also like answers to, you can actually upvote them. That means this question will move up the list and it will be the ones that our professor will see first. So our professor today is Alex Barrera. He is many things, including being a tea enthusiast, a father of 3, and he is a professor at IE Business School. He teaches in our Global Executive MBA. Thank you, Alex, for preparing this session with such enthusiasm, such care, and thank you all for joining us today. These sessions do not work without you. So I will pass over now to Alex, but I will request that all of you do fill in the survey at the end. That's where we will ask all of you what topics you would like to hear about next. So thank you for being here and enjoy the session.
Well, Sheena, thank you very much. It's my pleasure actually being here. Too bad we actually couldn't make it physically, but the joys and wonders of technology allow us to actually conduct this online, which is pretty cool. I think everyone is getting a crash course on how to do this stuff. So let me see. I'm going to share my screen now. There we go. Let's put it. There we go. Okay, so let me make sure I see the questions there. So as I said, first of all, thank you everyone for joining. I hope everyone is safe, and me being a Spaniard, we've been locked down for a long time now. So we're kind of losing our minds now. So if you see me doing crazy things, just take into account that that has to do. But without further ado, I would love to start talking about our topic today, which is space tech and the future trends around space tech. For those of you that don't actually know me, so I'm, as Sheena said, I'm a professor at IE, among many other things. I'm a serial entrepreneur. I started many different companies. I've also been an investor. I was one of the founding editors of tech.eu, and currently I'm the chief editor at thealeph.com, which is where I do a lot of the research around this kind of technologies. I'm a computer engineer, so I'm not an aerospace engineer. So if we have any space geek engineer in the house, please kind of forgive my unknowledge of certain areas, and I'll try not to go too nerdy, too geeky into the actual technology per se, but more on the strategic side of things. However, more than glad to go deep if we need to. So the first question I wanted to answer is, what is space tech, right? When we talk about all these concepts, it's good to keep in mind what's the framework and what is the definition of the actual technology. Because within space tech, there's a lot of things that we can unpack. And I'm going to try to give some very broad, let's say, groups or very, very broad boxes where we can fit in different things, so different aspects around space tech. So obviously, space technology has to do with anything space. There's been a new, what they call the new space movement, or the new space group of people, where commercial technology around space exploration has been skyrocketing in the past few years. So among the things we're talking about, the most obvious one are satellites. So all kind of satellites, big, small, different orbits, different sizes. So just to give you an idea what we're talking about, until very recently, like maybe I would say 10 years ago, 8 years ago, most of the satellites were large satellites over 1,000 kilograms, medium satellites between 500 to 1,000. Whoopsie. Something is blinking here. This is one thing that's always hard. Oh, there we go. Nothing on my screen. You guys cannot see my screen? Can you guys see my screen? Sheena, do you see my screen? Oh,
I don't. I can see a white blank screen. Do you want to try sharing your, can you
let me see.
your screen again?
Can you see it here?
Yes, I can see it there. Can you try and put that on full screen?
Yeah. Well, it was full screen right now, but well,
okay,
let's keep it. Let's keep it there.
Okay, perfect.
If that works, that's fine. Okay, so as I was saying, like all the different the different sizes for different satellites, and the what we've seen so far in the past few years were very large satellites, medium satellites that were very heavy, very equipped with many different instruments, and there's been an increase move towards smaller and smaller satellites being launched, what we call microsatellites and nanosatellites. I'm not going to go deep into the specifics of it. We will see different angles of it, but just keep in mind that the trend has been to the miniaturization of satellites. So when we're talking about satellites nowadays, in most cases, we're talking about small satellites, so microsatellites from 10 to 100 kilograms, or even very, very small satellites that are 1 kilogram to 10 kilogram. In some cases, they're called CubeSats, depending on the architecture that they've been used to, or that's being used to build them. Then there's another concept that keeps coming around, which is the different orbits, or where can you locate this kind of satellites. I think everyone that has been to school, or at least knows a little bit about satellites, has always heard about what's called geostationary satellites. Those are satellites that are far in what we call the high Earth orbit, and they tend to remain basically stable within the orbit, so it's easy to connect to them. So a lot of the meteorological satellites and stuff like that, or even the GPS satellite system, is in geostationary orbit. Now, there's the smallest one, which is called the suborbital part, which is, some of you might have heard about, like balloons being launched into sky by Facebook, by Google, by a bunch of other tech companies, where they are trying to be in between without having to use a very expensive launcher to get outside of the gravity well of Earth. Then we have what's called the low Earth orbit, also called LEO, and this is probably the most active orbit right now when it comes to talking about satellites. And the space in between the LEO and the high Earth orbit, which is medium Earth orbit. Some satellites move between low Earth and medium Earth because they have an elliptic orbit. But in general, when we're talking about most of the satellites now in this past 2-3 years, we're talking about low Earth orbit. There's one thing about these orbits, which is the higher you go, the less you have to move, because the satellite basically sees the whole planet. But the bigger the latency of the data is, right? So connecting between the satellite and Earth station, ground stations becomes a lower bandwidth and higher latency. Now, this is one of the reasons why a lot of the satellites have been moving to low Earth orbit, because it's closer to Earth, which means faster bit rates and less latency of connection. However, because it's so close to Earth, you need a lot more satellites to actually cover the whole perspective of the planet. And I'm not going to go deeper into that, but just so you get an idea of why people are actually trying to go lower in the orbits. Now, another big box within space technology is obviously transportation. The obvious one is from Earth to space. So that means all kind of rockets, including SpaceX, that a lot of you guys probably know. SpaceX is not just the fact that they have rockets, but that they have what's called a reusable rocket. So some part of the stages of the rocket actually come back to Earth. So the cost of launching is I wouldn't say cheap, because it's definitely not cheap, but it's at least a lot more cost effective because you're reusing these components. There's been a huge explosion in the transportation aspect from Earth to space. And there's a lot of different companies trying to do different kind of rockets. Before it was just NASA, ESA, and like the national space agencies in different countries. But right now there's a lot of private initiatives for either big rockets or very small rockets, where the goal is to actually put into orbit very small satellites. So now there's no need to have, well, there's always a need to have big rockets, but there's not that much need for huge rockets, but actually rockets that can put little satellites on orbit. Or that's a goal for a lot of people. So we're seeing kind of an explosion in the transportation aspect. Now, well, transportation, I said Earth to space, but it's also becoming increasingly important to have transportation space to space. So basically being able to move satellites into different orbits and keep changing them, correcting their orbits. So there's an increased interest on how do we do that? How do we move stuff in space and not rely on just lifting it and keeping the satellites up there? Then obviously communication is another of the big boxes, and there's gazillion initiatives around communication. Again, communication can be Earth to space and space to space. So basically long distance communication using radio frequency, which is what has been used so far. And different kind of antennas. There's a lot of research on the different antennas and the different ways of communicating these things. The goal here for some of the companies is, hey, wouldn't it be amazing that you actually have a satellite antenna in your home and you can communicate with the satellite network directly from your place? Right now, with the technology we have, that's not completely feasible, but it's getting there very, very fast. At the same time, we are also talking about space-to-space communication. So the more satellites we put in space, the bigger the need it is to coordinate the satellites, right? And to develop new ways of communicating with the satellites. There's a move or increasing need for better communication technology, both to Earth and between the satellites, and that's giving rise to what we call optic radio frequency, and more precisely the use of laser beams to communicate between both satellites and Earth. So there's a lot of research going on. There's a few companies that have real products actually working in that space and putting them in space. And so it's very exciting right now to see the change in the communication side of things when it comes to stuff that we put in orbit. Then there's another big box, which is servicing, that covers a lot of things. I'm just going to focus on a couple of them. One of them is creating satellites, right? Until now, you needed a very specific team to create a satellite, but it's getting to the point where we're starting to see satellite creation boutiques. So you're a big company, you want to create a bunch of satellites to service your product or whatever you need, and then you hire them and they will build a satellite for you at a, I wouldn't say inexpensive price, but a very affordable price for a big company. And this is becoming the norm, actually. Companies that are exclusively devoted to designing and creating this small micro and nano satellites for other companies. Forward at the same time, the concept of servicing space technology goes slightly beyond that, and it's all the kind of services that you can do not just in Earth but also in space. This is an example. This is a concept image of something called Orbit Fab. Companies called Orbit Fab, that they're on the verge of actually launching their first satellite, and their end goal is to create the gas stations for space, for orbit, basically. So they want to launch this big tanks with propellant in orbit, and then all the satellites that are around can actually connect to them and get their gas, so they don't have to destroy the satellite or do the reentry and eliminate the satellite from orbit. This is a big thing, and it's only happening now because now we have an increasing amount of companies putting satellites in orbit. So now it makes sense in a way. There's a couple of projects that existed years ago, but were eventually shelved because there wasn't any need for this, because there wasn't that many satellites. So why put this whole infrastructure in space when you're essentially not going to have any clients? However, this is becoming an increasing problem right now. So of course, the market is reacting by creating more servicing companies. Another big chunk is energy. While a lot of the satellites and a lot of the objects we put in space have access to stars, most explicitly the sun, to generate energy, there are certain parts of the space technology or the space architecture that might end up in places where they're behind the sun. So on the dark side of the moon, on the dark side of the planet. So essentially there's moments that might be very long where these machines, these satellites, or these lunar bases might not have access to energy. So there's a lot of research around, hey, can we actually create a mini nuclear fission in space, like a mini sun, and then we can redirect those beams to connect to our different devices and give them juice and give them energy. So this is still not a massive problem right now because we don't have a lunar base, but it is becoming an issue as we put more stuff in space and as we increase the longevity of some of these objects in orbit. And lastly, there's maybe the largest box right now, or the maybe not the largest, but the most active box within space technology is data analysis. Is okay, we put all these satellites in orbit, we put all these machines up there in space. Now, what can they do for us? Well, in most cases, the obvious use case is the taking of pictures all around the planet with different radio waves, with different filters, with different technologies to do the mapping of the Earth. And all that generates a lot of data, like gigabytes per hour of data that are being transmitted down to Earth and then analyzed. Now, it's not surprising that this space is the one that's getting the most traction, because it's cheaper to start a company where you don't need to have the satellite, but just you basically buy the data from the satellites that are already in orbit and then you analyze it. Now, the interesting thing is that this has changed drastically, because before, satellites were so expensive that downloading data from them was not accessible for a lot of people or for a lot of companies. Now this is becoming ridiculously cheap, because the satellites that are taking the pictures are very cheap to put in orbit compared to what it was before, which means that we are unlocking the potential of having access to all this data that was extremely hard and expensive to reach just 5-6 years ago. So there's a huge explosion. This picture that you actually see, this photograph, it's a real photograph from Chernobyl. This was taken by me. I downloaded the picture from the Sentinel-2 satellite, which any of you can actually do right now. You can go and take these pictures, and it's of the wildfires that are getting very, very close to the Chernobyl sarcophagus. And so you know, a lot of people are freaking out. But the point is, for me, it's mind-blowing that you can actually do this, that you can take this picture and check, not just look at the news and what people are telling you, but actually check how far the fire is getting. This is using a filter. So you see, like, the red area is vegetation, the black area is the burnt area of the fires. And that tiny little square on the top right hand side of the picture, that's like a small white square, that's the Chernobyl sarcophagus. That's where the reactor is concealed, basically. And that's 1 kilometer scale, basically. So more or less the fires are 1.5 kilometers away from the actual nuclear plant. So, you know, good news in the time of coronavirus. So anyway, power of images. Now, as I was saying before, the reduction on the cost has also been propelled by the increased amount of money that's being poured into the space tech industry, and it keeps ramping up. It's incredible the amount of money that's being thrown at it. And maybe the most incredible thing is that this money is actually doing stuff. It's not just getting lost in missions, but it's actually being turned into commercial applications, which is one of the things that has drastically changed from the previous era of space. Just to give you an insight, even now in the last trimester, the last quarter of 2019, they were still getting a lot of money. I mean, there's an average of around 40 investment operations in the space tech industry worldwide, which, you know, might not be massive when we compare it to other technology spaces, but taking into account the size of the deals that are happening, it's pretty incredible that they're keeping up the speed, and the amount of entrepreneurs and people getting into the new space race is incredible. It's like the new frontier of technology. These are the evolution on the different investment rounds on different years, and you can see a very, very nice picture that normally happens when an industry is maturing, which is you normally get a lot of seed investment at the beginning, so a lot of money for early stage companies, and as these companies start maturing, they're going to need bigger and bigger rounds. So you see an increase of Series A and Series B rounds, and how this is growing in terms of the percentage of rounds in the last few years, which is good. That normally is a good indicator that the space or the industry is maturing, and that companies that started 5, 6, 7 years ago are finally putting things into orbit, and they're needing more gas, more investment gas to keep going. So this is more for the curious people. The slides are online on my SlideShare, so you can already download them if you want to check them right now. And the interesting thing is just to give you a picture of who is investing on this. And it's interesting to see who is active and the speed at which, for example, space angels are investing, and the kind of companies they're investing is incredible. But as you can see, there's still not a lot of funds that are investing in this space. And there's a reason. The investment horizon for the funds is much bigger in the case of space technology. So a regular fund in technology normally gets returns or big returns after 10 years. In this case, the horizon is 15 to 20 years. So not a lot of money is that patient. And while there's a lot of excitement around the area, still investment is catching up here. And I will probably see more and more funds getting into the fray eventually. Just so you see a different perspective of this is the amount of companies around nanosatellites, specifically nanosatellites that have been founded in the past few years. And you can see that since 2012, the exponential increase of new companies being founded in the past few years has been astounding. Don't get me wrong, a lot of these companies will actually die, but the fact that there's this excitement around the industry is very, very good, because it means that there's a lot of people that are throwing new creative ideas around how to solve the issues. And even though a lot of these companies will eventually crash, we will see a lot of new innovation that will fuel the next iteration around this space. This is just so you see a different angle of this. The previous one was nanosatellite companies being founded. This is the evolution of the satellites in terms of sizes, and how basically around 2013, like the increase in nanosatellites started dwarfing the amount of microsatellite and the expensive heavy satellites that were being put into orbit until that point. So why now? As I was saying before, the dimensions of the satellites are much smaller. The components inside the satellites are off-the-shelf components. So right now you can actually buy a lot of these things that have capacity enough for you to put this into orbit and resist. Yes, link to the deck. There is, let me put it here so you have it, but it's very easy. It's slideshare.net, slideshare.net/the Aleph. And if I timed it well, it should be available right now. However, you have the link there. I'll share the link afterwards also. So, as I was saying, a lot of the components that we have right now in Earth are designed well enough to sustain the amount of radiation that you have in low orbit. I mean, they're definitely not going to last very long, but you can just throw something there with off-the-shelf components and stay in orbit for a year, 2 years, and it should be okay. In most cases, it is okay. Now, longer missions, higher orbits, different endgame, and depending on the kind of components that you want to build, like very sophisticated stuff might need a different kind of shielding. However, the prices are very affordable compared to other stuff. I'm a computer scientist myself, and I still remember how costly it was to just build a computer. For those of you that like gaming, how expensive it was to build a computer to be able to play Doom, or to be able to play multiplayer games in real time. It was really expensive, like the graphic cards and all the components you needed. Well, that's exactly the point that we are at with satellites, where prices are increasingly becoming cheaper. And part of it has to do with the normalization of the architecture for satellites. In 1999, there was a new architecture. There was a proposed standardized architecture that was called, or it's called CubeSat, that allows for a very normalized structure of how to build satellites. And this has dropped even further the prices around how much it costs to build one of these satellites. So that's one point. That's one part of why it's becoming cheaper. Than the amount of launches that we have for nanosatellites. It's increasing exponentially every year, so it's becoming also cheaper to launch them and more successful. So there's less, because the satellites are cheaper. Even if the rocket explodes or they have to abort a mission, you're not losing that much money as you did before. Before, if there was any incident with a rocket, that would mean hey, we just lost $500 million satellite. Now, and I'll give the numbers in a second, but now we're talking about losing maybe $20K, $30K, which is a lot of money, but it has nothing to do. It's basically a drop in the ocean compared to how expensive they were before. This is an idea of, because satellites are becoming so cheap, this is the number of nanosatellite constellations that are being planned and those that have been launched. For those of you that know a little bit about this, the largest one is run by a company called Planet.com, Planet Labs, and they do all kind of data analysis with the images they have, and they sell the images that are very, I wouldn't say cheap, but definitely not expensive stuff. And their satellites are really small and really cheap to make and to put into orbit. So as you see, they already have 387 satellites in orbit, and Spire, which is number 2, it's still pretty far behind. So, you know, there's a lot of movement here. A lot of these companies, if you look at the little green bars, like at least more than half of the constellations here at least have 1 or 2 satellites in orbit, which means that they're in testing phase, and most of them have happened in the last year. So between 2018, 2019, which is really interesting because this is accelerating it's going very fast right now. Just to give a little bit more intel, this is the nationalities for nanosatellite locations. So most of it are still coming, more than 50% are coming from the US. Big chunk for Europe, big chunk also for Asia. And just a brief mention for those of you that might be from Asia, China is surprisingly slightly far from the US companies, but it's catching up fast. Like the amount of companies doing rockets in China right now, like commercial rockets, is orders of magnitude bigger than the ones we're seeing in the US. So it's really interesting because even though still not as active as the US in terms of satellite activity, it's catching up, and it's catching up fast. So we'll probably see in the next few years a big increase of operations coming up from specifically from China, or probably Japan too also. Now, this is the range of how much it costs to do a satellite right now. It's between 10K to $500,000, depending on the weight of the satellite. The average, or at least the satellites that SpaceX is using to build their own constellation, that I'll go into depth in a moment, it's called Starlink, and it's roughly around 300K. And they're capable of chunking around 7 of these satellites every day. So let me repeat that. They can build 7 satellites in a day for 300K each, which you may say, hey, it's a lot of money. But when you put things into perspective, it's actually very, very cheap. Now, for smaller satellites, the ones we saw for Planet Labs, there's not a specific number because it's kept private, but a lot of the guesses is it's in the thousands. So it would be probably around 10K to 15K. So on the lower end of this, and they can do them very fast also. So, you know, it's very, very affordable right now to do space technology. This is a breakdown on the different launchers that nanosatellites are using, and how the mix keeps increasing with new rockets being put online, commercial rockets that all these satellite companies can actually use to launch their satellites. Just so you get an idea, this is the breakdown of the past few years of nano and microsatellite launchers. PSLV is an Indian rocket, and it was by far the most active one in 2019. Antares, which is American, Soyuz, which is Russian, the Falcon Heavy from SpaceX, Kai-2, which is Chinese rocket. It's been pretty active. Electron, which is American rocket by Rocket Labs, Falcon 9, also SpaceX, and then a bunch of other rockets. This picture is definitely going to change in the next few years. We're going to have a lot of other players launching things into space. So this is just becoming extremely heated space. Now, to put a satellite in orbit, we're talking of a price tag of around 40 to 220K per kilogram of satellite. Okay, so it is expensive, but let me go back for a second on this slide that I didn't talk. But if you look here, this is like the leaderboard that the guys at Spacework keep. And the target launch price for some of these rockets is very affordable. 33K per kilogram, 57K, 40K per kilogram. It is expensive, but compare to the 3 million, 4 million, 10 million price tag that we had just some years ago, this is incredible. We're not there yet. I don't think that most of these rockets are capable of putting something in space for under 40K. But still, it's pretty impressive that the end goal is to lower that price and to get it into a very affordable price. Now, if you're a big corporation, being able to do this is now within range. Okay, so Sheena is talking about polling time. So we have a couple of questions, a couple of polls that we want to launch for you to answer. There's no grading, obviously. It's just like to see your opinion and your perspective on what we've been talking so far. By all means, please add any questions on the Q&A slot so I can answer as I keep talking, or if you have doubts of anything I've talked so far, please do. Okay, the poll just went live. And again, any questions so far that you're interested, please drop it and I'll answer it in real time. So far so good. Everyone's happy. We're enjoying this. Very happy. Okay, so let's keep moving here. There we go here. Let's move this stuff here. So this is another perspective of how cheap this has become. This is resolution on one of the axes versus the price per photograph or satellite image that you can download, and how right now we're getting to a point where Dove, for example, Dove and Rabbit Eye are two of the satellites from Planet Labs. So Dove, it's getting to a resolution of nearly under 4 meters resolution, and it's roughly on the between $300 to $400 per image, which is incredible because it's it's incredible resolution. Nearly, I wouldn't say military grade. You can get there, but it's definitely a little bit more expensive. But it's way better than we had before, and to do a lot of stuff is it's very, very interesting because you can do a lot of powerful analysis with those images. Now, I'm going to go a slightly deeper into a couple of strategic areas within space tech that are very heated and that I believe are very interesting. The first one, as I said before, is communication, the communication space. There's at least 3 companies, very large companies, that are trying to build the next generation broadband network in space. So everyone is talking about 5G right now. Well, these guys are building the 5G of space. And in the case, the largest company or the most advanced company so far is SpaceX, which some of you probably know because it's run by Elon Musk. So the same guy from Tesla and a bunch of other companies like, can't remember the name, Solar or something. It's the Solar City, I think it's the name of the Solar one that got acquired. Anyway, they've launched through SpaceX, which runs rockets. So the Falcon 9 and a bunch of other type of rockets. They've been launching in the past few years a massive broadband communication network in low orbit that's called Starlink. It's reminiscence of Terminator, so Skynet kind of stuff. And their goal is to give broadband operationally in 2020, so this year. Well, after coronavirus, we will see what happens with that. But so far, they plan to achieve that. They've launched to date 362 satellites out of the 1,600 they want to launch to cover the whole world. The last launch is happening today at 9:16 Central European time. So if you're interested on this stuff, you can actually follow the launch. So that's going to be interesting to see how it goes, especially with the emergency situation and the pandemic worldwide. The fact that they're still launching these things is pretty amazing. Starlink is by far the most advanced space broadband communication network right now. And I'll throw a question here for everyone. What is going to happen to the ground telecommunication companies when this stuff goes online? Because they're basically going to be able to wipe out a lot of telecommunications worldwide. And the fact that they can actually connect any user from any point in the globe is pretty impressive. And it's really going to change how we understand telecommunications and telecommunication services in the next 10 years. Okay, so we have the results for the polls. I don't know, Sheena, you wanna show them? There we go. So 74% think that COVID-19 is really going to affect it. Yes, wow, 91% think that this is going to be the future. Very, very excited about this. And well, SpaceX Starlink, we were just talking about this, will be the first broadband network. 81% think it's definitely going to be, wow, that's impressive. I have to agree with the results of the poll because I definitely see it working in the same way. Let me see if we have, oh, 2 questions here. Yes, we have one question around OneWeb, which I'm just gonna answer in a second. So I'll go with that. And it's definitely, coronavirus is definitely part of the impact, but there's a lot of other stuff behind this stuff. Let me finish with Starlink, and then I'll go deep into OneWeb, which I already have slides also for this. So this is a tweet that Elon Musk posted in October of last year. Okay, so this is old news already, but this is the first tweet that has been thrown connection through Starlink satellites. So I wonder if we are going to see the Starlink network, at least in North America, happening sometime during this year. That would be, I know for a fact that it's being tested and it's operational for the US Air Force. So that's actually real and it's happening. Now the question is, how is this gonna, when is this gonna be available for commercial use? We will see. Now, as some of you pointed out, the other largest company in the broadband space, broadband communication space, was OneWeb. They did a joint venture. It's a joint venture between Airbus and OneWeb company. They did a partnership also, a merge with Intelsat, which was a big drama. They got sued. This was just in November of last year, how SoftBank, which was one of the backers of OneWeb, was trying to get this thrown out. And this was March 21st of this year. So this was less than a month ago. They launched 34 of the OneWeb satellites. And this was March 27, OneWeb files for bankruptcy. Okay, so yes, there's a lot of stuff happening here. So I'll try to answer this first one live. OneWeb is bankrupt so far. One of the reasons they've been talking about is the fact that SoftBank pulled out of the deal of the next financing round. Part of it has to do with COVID-19. Another part has to do with the fact that SoftBank's Vision Fund is under fire right now. They're going to post, I think, losses north of 16 billion this year in the fund, just in the fund. So they're cutting the losses, and clearly this was one that was pretty clear that was going to happen. Now, right now, they're trying to sell their radio frequency rights. So we will see what happened with that, because there's other contenders trying to get into this race. One of them, and I'll just fast forward here for a second. One of them is Amazon, that announced recently that is getting into the space race. Now they're pretty far behind any of these 2 players. They still have to get the licenses. So it might happen that OneWeb licenses might be bought or auctioned off, and maybe Amazon can get their hands on it. They still don't have the green light to do it. So we will see what happens. Let me check. Terrestrial communications will always be more reliable than space-based communications, so there will be transmissions through premium services. Might be. To be honest, right now as it stands, you're very right. Let me answer this one. Terrestrial communications are way more stable. They allow for larger bandwidths, especially with the deployment of 5G, and especially in high concentration areas like urban areas. However, this is changing, and it's changing fast. I was telling Sheena before that I did this research on space tech in 2018, and updating the research this week, and I was surprised. It blew my mind how fast this is going. So while you're right, we will see what happens, because the kind of innovation that we're seeing right now, the trajectory of this innovation might enable some really high-speed communications with space that are even more reliable than terrestrial communication, especially in areas where you don't have the infrastructure. So we're talking about densely populated areas like big cities. Definitely terrestrial communication is going to be working, but the moment you start getting away from there, and taking into account that most of the population now in Earth is migrating into urban areas, the fact is that that reduces the incentive to expand the terrestrial communication infrastructure. So we will see what happens, but I'm very bullish personally. Again, don't have to trust me. That's why we're having this talk, for everyone to have a different point of view. But in my opinion, it might get to a point where it's as good, at least in many areas that are not covered by densely populated areas like, New York City, Tokyo, some of the Chinese cities like Shanghai or Beijing, or city like London. What about the acceleration of downstream applications and services due to COVID? Thinking about COVID impact analysis, images to see pollution level, manufacturing output reduction. That's a very, 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 very good question. And I'm actually going to talk about this in a second, so I'll keep it here so I can talk about in depth about this. Space tourists versus space mining. Very good point. I'll delay this question later on because I'm going to be talking about space mining at the very end of the talk. So I'll bring this up later. Could this trigger now a military race to claim prime location for space? Definitely. This one I can answer right now. Definitely. There's a space race as we talk. One of the things I have at the one of the last slides, but I'll advance it here. One of the things that you can see with the pandemic is that most of the space programs, both public and private, are still getting exceptions and exemptions to keep putting things in space. Like, it's a priority for a lot of governments to actually do this, even if it's from the commercial branches of different countries. They're getting licenses to keep throwing things in space, even as the pandemic rages on. So that can give you a very clear idea that this is part of the militarization race that we're seeing right now. I don't want to polarize this, but it's definitely between the US and China, but it's involving a lot of other pieces. Europe is kind of sandwiched in between because Europe has a very, very large market share around aerospace. So we will see what happens. And more importantly, we will see what happens when a lot of the aerospace companies, if a lot of the aerospace companies end up being bankrupt, because that's another point, and we will talk about it later. Low latency, LEO, with its significant RF power budget, will enable rapid expansion of terrestrial 5G connectivity, because as fiber surrogate, it's far cheaper than installing fiber-based infrastructure in rural and developed. What are the cultural impacts of this reality? That is a very, very good question. I've been thinking about this, especially, I don't know if you guys remember when we had the Hong Kong protests happening, the Beirut protests happening, the Iran protests. The first thing that all the governments did in those places was to shut down 4G connectivity in different areas where the protests were happening. It was very interesting to see that a lot of the groups were trying to do like mesh networks on the ground and using the systems to try and piggyback on the connection and actually have data during the protests. And I was thinking that the fact that eventually space communication with broadband communication might become a reality might change this stuff. So it will definitely have a massive cultural impact in the sense that it will be much harder to control communications going to space. I'm not saying they won't try to do it, and actually to a certain degree SpaceX has to ask for permission to give their services in each country. But one thing is asking for permission, and another different thing is the fact that if you have an antenna, you can point it up, you can actually get the connection, right? So we'll see what happens with that, but it's definitely, I believe it's going to have a powerful cultural impact, especially around the diffusion of information, around governments that try to tightly control the flow of information. That's probably going to be or become harder with these things, among many other different things. Don't get me wrong. I mean, there are other stuff that will definitely be impacted by this. Well, I'm going to keep going for a second. I'll stop here and then I'll keep answering the next questions. Okay, so we keep moving and I'll go back to the questions in a moment. So as I was saying, Amazon is also trying to do this, pretty far behind in terms of space technology itself, but very advanced on the data infrastructure aspect. And I'll talk about this in a second. Also mentioned that Facebook said that they're gonna try and do constellations. I don't know if it's some kind of a joke, but there's actually a company, not under the name of Facebook, but there's a company that's about to launch a satellite probably in 2020, if the pandemic allows. I wouldn't be betting anything on that, to be honest. Like this takes a long time to get there and to do the tight integrations that you need to make it affordable, or to at least have enough margin to make money out of this. So right now we will see what happens, because it's looking clearer than SpaceX is going to have dominant position right now on this. We will see what happens in Asia and what comes out of Asia in the next few years. But as I said before, it's still slightly ahead of the curve in terms of technology and capacity to do this. Now, I'll go deeper, and some of you were pointing at this. I'll go a little bit deeper into the impact of data analysis around satellite images. So just so we are clear on how this is normally working, you have a satellite constellation on low orbit or medium orbit or high orbit, depends on the provider. They transmit their images, very, very large images to ground stations, and this gets pumped to sometimes the same company, sometimes image brokers, which basically allow other people to buy these images. There's a bunch of them. Some of them aggregate images from different satellites. Others are their own, the satellite owners also. So they kind of integrate the whole value chain. And the next step is analysis companies that download or buy these images. They don't need to have space infrastructure. They basically buy these images and then they run analysis on these images, and increasingly more sophisticated analysis, because increasingly these images are better, the resolutions are better, and the frequency of transmission of these images is increasing. So you can do a lot of other, I wouldn't say real time, because that's still not affordable for a lot of people, but quasi real time in some cases, or daily and frequent analysis of these images. Now there's a lot of combinations here, but there's like 4 big things that are being disrupted by this capacity. First one is government accountability, and I'll go deep into it in a second. Second one is financial markets, and third one is health issues, and I'll give an example of this. And fourth one is insurance. So I'll go directly into it because we're kind of running out of time. As I was saying, accountability, you can right now for free check some of these images. Both of these images come from the Copernicus constellation of satellites from the EU, from the European Space Agency. One is images, the other one is on the suspension particles of fires. And you can see the plume of the wildfires coming from Chernobyl, and probably on radioactive isotopes or radioactive material being blown by the winds. And you can actually check it right now in real time, which it just blows my mind, because it's like, yeah, the government says this is under control. Well, we'll see about that, because the image paints a very different picture. Same goes for accountability around things like climate change. This is an image of the 13th of April that I took on the analysis of nitrogen oxide. So basically diesel fuel consumption. You can see the Rotterdam port over there and all these ships and the ship lanes going back and forth. This has been observed for years, but now it's accessible to anyone. I mean, literally, you can just go online and check this image and see how it's going. So when they talk about, yeah, we're gonna agree with the climate change accord and whatever, well, this is proof that in most cases it's not happening, or it's not happening fast enough. Same goes with deforestation issues. This is a sequence from NASA from 2001 to 2016 of the increase of rubber plantations in Cambodia. You can check this. There's been gazillion of images of this, also with the fires and deforestation in the Amazon rainforest. Now, well, this is for accountability for governments. It can also be wars or fires or villages being torched down that you can actually check right now when it's actually happening. So the transparency of the governments is ideally increasing, because these tools are becoming available as Google Maps is right now. Now, from the financial market perspective, this becomes increasingly interesting for a lot of the economical powers in the world. Right now, you can do analysis of crop yields and see how crops are going to be. You can invest in futures and options around different crops. The same goes with merchandising, with how goods are being moved all around the world. You can count the amount of boats. You can see where those materials are being offloaded, where they are being unloaded, how fast are they being moved. And this way you can actually predict how the materials are going to be sold in the market and get the upper hand. The same goes for energy. These are some images of satellite and how they actually measure the capacity of their oil refineries based on the shadows that the satellites capture. This is pretty, I mean, this has been happening before, but the amount of companies doing it now and the affordability of this is just plummeting. So this was only accessible for very, very rich companies. And now this is becoming accessible for nearly everyone. So kind of interesting to see how this is shaping. These are images from a Finnish company. It's called ICEYE, where they do radar. So they have in orbit probably one of the most advanced radar right now. And you can see through a lot of this stuff. So it's really fascinating. It's not just like static images or pictures, but all kind of wavelengths and analysis that you can download right now. This is an image of the Tesla Gigafactory in Vegas, in Nevada. And this was used to actually predict the stock price of Tesla, depending on what Elon said that was their capacity of production, and to actually check against a real thing. So this is actively being used by investors right now. This is an analysis of Planet Labs on metal storage worldwide, or steel and general metal storage. And here you can see the real impact of the trade wars between different countries, and how in March, between March and April of 2018, there was new sanctions imposed and new taxes imposed on steel and metals, and how this upended the balance of who was importing and who was doing this stuff, and how it went slightly better for the US and how China had to reduce their output. But this is the interesting thing, is that this is not the official numbers. This is picked up by the satellites. So, you know, it's another indicator to do stuff around this. Another tool that's being used with data analysis is counting cars. To see the performance of retail spaces, of ports, of cities and stuff like that. And this is quite interesting because there's been a couple of studies that that analyze the correlation. If you use this information to invest in shares of companies in the retail space before they made their numbers public, you would be beating the markets roughly nearly 5%. That's a lot of money there. So, but again, the interesting thing is that this is becoming very affordable for everyone now to do. Okay, this is another example of car counting here in a city, in different retail spaces. So you can actually make decisions on, hey, should I put money in this company or that company? Another space, as I was talking before, is insurance. So this is the number of natural relevant disasters happening since 1980. And for those people questioning climate change, this is a clear indicator that, you know, maybe this happened 120,000 years ago, but it definitely wasn't happening 1,000 years ago. Okay, so for a lot of insurance companies, getting into this natural risk assessment, natural disaster risk assessment is becoming increasingly important. So here you have analysis on insurance claims. And if people are trying to you know, squeeze you or say, hey, you know, I was affected, but I wasn't affected, or I was affected and I didn't realize, and you can cover it, and a lot of that stuff that also happened with a bunch of the hurricanes in the US. This is a risk model analysis with historical images of an area and how the flooding has become increasingly more dangerous in certain areas, and then you can sell these models to insurance companies for them to reassess the risk of building around those areas. This is also for insurance companies. This is an analysis by Planet Labs of the building of the Tesla Gigafactory in Nevada. And if you are an investor in real estate, you can also check this stuff and how to insure your property and what's going around. And lastly, there's been a couple of uses of this information for healthcare. One of them is assessing if there's a pandemic happening by analyzing the amount of cars in the hospitals. And there's a pretty close correlation with this stuff. This is not being used right now massively, but I wonder if after this coronavirus pandemic, we are going to see a lot more companies using this kind of models to see if they should allow travelers to come in, if there's a pandemic happening in another country and the alert is not, and they're not being alerted to it. So we might see some companies, at least from a national perspective or from a security perspective, we might see some of this stuff panning out in the future. Just an interesting notice here, the US just banned exports of the usage of AI and machine learning of satellite images. This is from January of this year. So this is how massively the space is growing when a government is forbidding companies from exporting this technology outside. Okay, so this is talking about the space wars and things like that. This is another area where it's getting heated. And I'm going to get now and answer some of the questions that we had before. Okay, this one.
So, Alex, just regarding the questions, the ones that you chose to answer live, you can dismiss, and you'll be left with questions that are left.
Yeah, that's. I was actually checking that right now. So here we're going to talk into the future trends of what's actually happening. And I try to structure it from things that are already happening to things that will happen in the future or that might happen in the future. Okay. And some of those things are related to some of the questions. I'm, however, going to double check right now. Let's see. NASA outsourcing projects to SpaceX. What are your thoughts about the European Space Agency? Do you see any privatization of projects? In addition, could you share with us the investment outlook for the space industry, since you mentioned Europe has second largest market share in the industry? Okay, so two questions here. I think we're going to see, and we're already seeing it, an increasing privatization of space projects. There's more and more private investors, hedge funds, and big money that's pouring money into space. One of the reasons is what I was just talking before, the fact that you can do better predictions and better investments with that information. It's fueling a lot of this stuff. So people are seeing, or let me rephrase this, we are about to change epochs, and coronavirus is accelerating this change of paradigm around innovation, and space tech is one of those technologies that are being propelled with these things. And eventually investors are going to try and find new frontiers to invest and get better returns, which means that they're going to start investing heavily in things like this, because the upsides, the risk is massive, but the upsides are also massive, which means that the moment that capital, what we call financial capital, starts getting lower returns on the current technologies, which will happen probably around the next 10 years, they're going to start trying to invest in things with bigger risk but bigger upside, which means that there's going to be an acceleration of this privatization around space technology and privatization of what is now public space agencies projects. There's a lot of collaboration right now between public space agencies and private companies, to the point that the people are basically the same. They just keep changing sides from one to the other one. But the balance is starting to shift towards the private sector. And oopsie. Well, this is moving. Let's see, what else do we have here? Data satellites have been seen as service providers and with limited purposes. With now launch costs reduced, what kind of commercial offerings you foresee? Well, I just talked about a couple of the ones I'm seeing, and probably we're gonna see a bunch of new uses of this stuff. I've been trying to do the research and see all the different weird things that people are applying this technology to. And there's a limited list of those, let's say, use cases. But the interesting thing here is that because the cost is drastically being reduced, the amount of entrepreneurs that are picking up space technology as a space or as a vertical to do creative things is increasing drastically, which means that it's kind of what happened with the internet after the bubble in the 2000 and 2001, that there was this massive investment in infrastructure that wasn't really used. There was like, out of all the fiber optic that was thrown around the place, at the time they measured that it was only 1% of that infrastructure that was being used at the Senate of the internet bubble. Right now, the moment that crashed, a lot of other companies started using, and now we're using a lot of that infrastructure, and it has accelerated our disruption capacity or disruptive innovation capacity. So it's interesting to see that the same pattern, it's repeating itself right now from a space perspective. So we will probably see increased number of use cases in the next, I would say, 10 years of creative people using slightly different signals and slightly different technologies to combine these things with what we have in Earth and do other stuff. So we will see. Okay, let's see. How does the future of multimedia services based on satellite communication, Sky or Sirius XM look like? Do they stand a chance against internet services like Netflix or Spotify? This is quite subjective, but I would say they don't. I think that everything is going to go online right now. And from a terrestrial point of view, we will see, as someone was suggesting before, we will see what happens and how expensive it is to do right now broadband communication from space. Because obviously this is still very early days, and even though the prices for the actual infrastructure are getting very, very low compared to what they were before, when you translate this to a customer, the barrier is still very high yet. So we will see what happens. So you might see maybe 4 or 5 years of transition period for these services compared to the actual internet-based ones, but I don't see them lasting much longer, especially with the speed of deployment of 5G. So forget space technology for a second. The 5G race is still on, even though the pandemic is pushing this stuff. So we will probably see an increased amount of services just going online. And well, there was a lot of doubts, and the Netflix shares were getting hammered before the pandemic, and now everyone is using it, and the usage is skyrocketing. And even the Hollywood studios are trying to sell the production that they cannot put in the cinemas to them right now. So think about the pandemic as an acceleration of all these trends that were already happening. So probably we've yet speeded up this roughly like 5 to 7 years through this whole ordeal. And the longer the pandemic exists, the more acceleration we're going to see. So I don't believe they're going to survive this. They might survive under a different name and under a different service, but not as we see them right now. Okay, so Sheena is answering, taking my questions out as I answer them. Great, good team. So we still have a couple of questions there yet to answer. So I'm gonna go into the future trends, and the one that was pending will be answered here. So speaking of trends, 3D printing, that it's probably most of you have been seeing in the news how the 3D printing community is trying to help build respirators for hospitals. But 3D printing, when it comes to industrial grade elements, the #1 industry that's using this is the space technology industry. Specifically, they're using 3D printing increasingly to build more and better sophisticated components for rockets and other parts. But essentially, rockets have been the one that has captured the imagination of everyone. And this is an interesting quote from Peter Beck. The image that you have at the back is from Rocket Lab, which is probably the rocket with the largest amount of pieces that have been 3D printed in high-grade metal. And I think the quote was very interesting to say, look, this is not just about printing a little tiny piece. This is about redesigning how we understand manufacturing of these things. And so they are printing huge, sophisticated parts of the engine that before would need different movable parts to be produced independently, and now they're putting it all together. So this is really changing and lowering the cost of production of these things. And more importantly, it's allowing all these space tech companies to produce things faster. So it's becoming a very agile industry. Well, quotes here, agile. Okay, as agile as you can be in space with all the quality requirements that you need, but it's becoming more agile, way more agile than it was before. And the fact that a company like SpaceX can actually create satellites that can be put into space and create 7 satellites per day, it's absolutely mind-blowing. Okay, and that is due to a lot of this stuff, the normalization and the use of 3D printing in this space. Another stuff that is happening, that's already happening, is the evolution of ground station services for big quantities of data, of incoming data from space. Okay, so Amazon already has, since May of last year, what's called Amazon Web Service Ground Station, which is a service that it's ground station as a service, basically. So you just get a slot and say, okay, I'm gonna download all this stuff to Earth, and they give you a slot. You can put your satellite to dump all the information, and then they will spread this information directly all the way to the closest S3 bucket, so basically the Amazon Web Service data storage, and then you can do whatever you want there. And the fact that they're integrating all the infrastructure, the data infrastructure on the ground, is extremely visionary, and they are the only ones that have that, and they're already capturing a big chunk of the market. However, the space part is the one that they're kind of missing, and they're trying to build up. But the ground segment they have, and they're basically killing it. I think it's like roughly like a quarter right now of the companies that pump data back to Earth, especially of micro and nano satellites, are using to some degree this kind of infrastructure. So we're going to see an increase as commoditization of this stuff. This one is probably my favorite, and it just blew my mind when I was doing the research, which is, and it's already happening, the in-space computation. So why would you want to do all this AI and machine learning analysis of these images back in Earth if you have a cloud computing floating in orbit, and you can just throw the data there and do the computation there and just get the intelligence back down to Earth instead of that massive 4 GB archive of pictures or terabytes of pictures, right? This is real. This is happening. Lockheed Martin just launched in January of this year the first mission that's called Pony Express 1 with a bunch of infrastructure or satellites inside that's called HiveStar. Or they also copyrighted or trademarked the name Space Cloud. So they're trying to put this computational infrastructure, very flexible computational infrastructure of cloud computing in space. And this is not just for the technology in orbit, but also for missions that are trying to go to Mars, to the moon, and stuff like that. I think this is the stuff of science fiction, and the fact that this is real just blows my mind. Still, a lot of stuff to go there, but the direction is heading there. Then another stuff that is already happening, it's in-orbit relay networks. So basically, relay satellites are those satellites that you use to bounce signals from the satellite in orbit to another satellite that then relays this information back to Earth. This is done because in most cases, the satellite might not be on top of the ground station, so essentially cannot communicate with the ground, but has a lot of information that needs to be communicated. So there's an increasing number of companies, Analytical Space is one of them, pretty well funded, that are building this network of cheap nanosatellites in space that connect through laser, so through optic radio frequency, increasing the bandwidth between the satellites and allowing any satellite to throw data to their network. And this network basically to push all the information down to Earth very, very quickly, instead of having to wait like one day until the orbit it orbits around the planet and finds a slot for a ground station. This is important for the fact that if we can do this, and then any satellite can communicate with Earth at any point in time, then instead of having data and pictures once a day or twice a day or once every hour, we might have it once every minute. And that is massive. The scale of innovation that you can do with that is a very different scale. And I'm gonna get a little creepy here, but imagine this stuff happening like a massive surveillance at an Orwellian scale in real time. This might eventually happen. Now, another future trend, in-orbit servicing. So as I was saying before, more and more companies are feeling that now it's the moment to create services for stuff that's in space. One of them is the Vigor ride in space transportation by Momentous company, Momentous Space. This is about to launch sometime this year if they don't get delayed. And it's basically a propulsion system to, it's like a taxi for space, if you want to look at it like that. It's like, hey, instead of paying a lot of money to get into a certain orbit or waiting a long time to hitch a ride from a rocket that puts you into a specific orbit, why don't you hitch up a ride with us? We will get you to the most affordable orbit, and then we will hit you with our Uber for space. We will take you to the right orbit for an affordable price. So basically, it's like the fragmentation of transportation and space, which is, I think it's also mind-blowing. Like, they already have clients for this stuff, so we'll see how this evolves. Again, we are dabbling in the science fiction space, okay, but this is going to be launched. Another in-orbiting services is automatic refueling of or repairing of satellites in space. This is real. This happened in February of this year, so 2 months ago. It was the first mission, the first connection of 2 commercial satellites between the mission extension vehicle, which had refueling capabilities, and a telecommunication satellite. And they refueled the satellite. It was a commercial satellite. They refueled the satellite, and they gave the satellite 5 more years of service. So now imagine for a satellite that might be 300 million, 400 million, the fact that, hey, by a small price, I can refuel and restock the satellite and keep it operational. That's a big thing. And this just happened. So this is not science fiction. This is already happening as we speak. Another future trend is the development of commercial available new propulsion systems. This is also from Momentous, which it's a water-based plasma engine. The reason why this matters is because it reduces the cost of production of rockets, and it also allows for safety issues. If you have an engine that works with water, you don't need to pressurize it. You don't need to make sure it's protected because it's not toxic. And this is really important because then if there's an accident, it won't be a catastrophic accident. So there's a lot of new research in this space that's really happening as we speak. This was tested in September of last year. So again, it's not science fiction, it's actually happening. Same thing goes for new ion engine propulsion systems. This was tested in February, or it was released in February of 2020, and it's about to be tested in space very soon. I believe it was this year or 2021. Let me keep going there. I won't go into depth here, but because there's more data, because there's more people getting engaged, because there are more satellites, there's an increasing use of artificial intelligence beyond the data analysis. So things from manufacturing and automating manufacturing to creating smart communication channels and letting the satellites decide how and when to communicate. to the coordination of this massive thousands of satellite constellations, to satellite collision avoidance, debris prediction, failure prediction. All these predictive models of AI that we're seeing right now in Earth are starting to be thought to be put into space. So it's a matter of time until this becomes the norm for a lot of the space operations, which until very recently have been extremely manual, to be honest. Now, obviously, this also brings the question of cybersecurity and how do we apply cybersecurity to space, which is another big thing. Space manufacturing is another of these weird future trends. This is a real project, joint venture or investment from NASA into a company that's called Made in Space that are building what's called Archinaut 1 and has a test flight, the maiden test flight in 2022, which is a space 3D printer that's going to print a massive 3-kilometer solar panel and assemble the panel in space. So basically, we're getting to the point where there's I wouldn't say a massive amount of companies, but there's at least like 3 or 4 companies worldwide trying to build this, to create technology that allows you to build bigger and more massive structures in space. The problem right now for things like this is if you want to do a 3-kilometer wide solar array, you need to pack it up in a rocket, and you can fold it in a certain way, but it's just a physical limitation of how you can fold this. If you can build part of this stuff in space, then you can assemble the whole thing. So you can only just get a normal rocket, put all this stuff in space, and then get the Lego built by the robotic arms in space. So that's exactly what they're trying to achieve, and it's coming. It's definitely coming. The same goes for human habitats. So there's a couple of companies that are building what would look like for human habitation for a space moon or a Mars mission. This is not science fiction. This is rendered from the European Space Agency, but this is part of the plan from NASA of the Artemis mission and the Artemis base camp for 2024. We're talking about 4 years. We're not talking about 15 years, but actually 4 years. And they're scrambling to find people that can help them build the infrastructure needed to build this stuff in space. And finally, we'll get back to asteroid mining, which is probably one of the most eye-catching or eye-popping topics that we had at the beginning of the space tech race, of the new generation of space tech, and that went bust recently. Most of the companies in that space went either bankrupt or they were bought by other companies. However, and this is the interesting part about asteroid mining, it created a lot of interest, it created a lot of investment, it created a lot of new technology that's now being reused for, let's say, less ambitious parts of the space tech race. Actually, a lot of the teams that used to work in these companies are now co-founding new companies that are trying to use what they knew into other spaces like data analysis, like space manufacturing and stuff like that. So probably this was like the gold rush part, but in the same way the gold rush enabled the spread of the train infrastructure, of the colonization of the west part of the west coast of the US, this is also creating the same kind of effect. So we're still pretty far from this stuff. So anyone saying otherwise is not really seeing the sequence, especially the investment and the consumer adoption of this stuff. But a lot of the technologies that were designed for this or were thought for this are now being reused for more affordable things. So what I was talking before, like water propelled engines, one of the advantages of having water propellant is that you can actually mine water from comets and from the moon or from nearby asteroids in space. So you don't need to throw the spacecraft again. Now, the whole operation is still very far into the future, but the fact that we already have an engine that allows for autonomous refueling in space starts to gain strength, right? And this is the problem, is you still need a lot of other pieces to be built, tested, and used in a continuous fashion before we can get to the point of asteroid mining. But we will get there. I definitely have no doubt about that. So I hope that answers part of the question we had before. And space tourism versus space mining, I definitely believe space tourism is way more achievable than space mining right now. Way more achievable. Space tourism, you need a base or you need a suborbital flight, and that is doable right now. I mean, the fact that there's still a lot of risk is still there, but we're approaching that point pretty fast. As I said, the lunar landing, the lunar mission for a station there is 2024, so it's not far now. Space mining is still far from, but not because of the technology itself, but because of the investment horizon that you need to achieve that. There's just not a market big enough. In the same way, there wasn't a market big enough for in-space servicing 3 or 4 years ago. It just didn't exist. If you remember the chats we had before, it was the increase was exponential in the past 5-6 years, right? So it made a lot of sense. Okay, let me go here. Once space broadband becomes a reality, more applications are set to increase along with the traditional service providers. Hence, will the amount of data consumption increase? And as a result, do data centers become an integral part of this? Definitely. Think that the increased resolution of images and spectral images and stuff that we're pumping from space is going to increase, both because of the amount of satellites and the resolution and the quality of the signals, of the instruments that we're putting in space. Which means that we will probably dump more information to Earth, at least in the beginning, at least until we have computational resource in orbit, which, as much as I personally think that's badass and that's incredible, there's still a lot of stuff to figure out till we get to a point where that's the Amazon Web Service or the Space Web Service of in space in orbit. So until that happens, we'll probably be dumping a lot of information to Earth. So anything and everything that process data in large scale and fast from ground stations to data facilities or data processing facilities is definitely going to see an increase. But this is not just related to space. This is going to happen everywhere. I think also the fact that the more people you have connected, the more data that you create. So even if you only use a part of the space segment for the broadband communication, as someone was pointing out before, still right now terrestrial communications are more efficient, which means that you might only use a little part of the space segment, and then you will continue the data will travel across the Earth's surface. Now, the fact that you're enabling more connections means that more data is going to be generated, no matter if you're using the space infrastructure or if you're only using a tiny bit of infrastructure just to connect until you hit a relay point and you put information through the surface. Interesting also, space debris clean as an interesting reality in Italy, for example. Very good point. As I was saying before, there's an increasing amount of people doing research on both the autonomous capacity for satellites to remove or to get themselves out of harm's way because of the space debris. And at the same time, there's an increasing number of satellite companies that are obliged, or they are kind of being forced to have deorbiting protocols. So now it's not enough to just put the satellite in orbit, especially in low orbit where it's getting very crowded, but you are being forced to have a mechanism to deorbit the satellite so you don't get stuff there. So in a way, that is a field that's actually very interesting, both in terms of collision avoidance, also debris prediction, how to predict the trajectories of this stuff in a way so you can move the satellites ahead of time instead of triggering the collision avoidance system. And also, at least from my point of view, also an interesting point of view of recollection of this cleaning debris in orbit, maybe even recycling it in space. That right now it's not happening, but it would be interesting to see if you get a increasing amount of services of in-space servicing if it might be interesting to, you know, get this stuff and take it to the moon and build a recycling facility in the moon, maybe, and just like dump it there and use it as material that can be reforged to do new things in the moon station. That, again, science fiction as of now, but could definitely happen. Is within the realms of imagination and logic in terms of the structure. And what does it mean to refuel a satellite? Good question. So most satellites, especially those that get into orbit, even though they are put into orbit by a large rocket that takes them out of the gravity pull of Earth and place them in orbit, then there's a small space between being released in space and getting into your specific orbit around the Earth. To do that traveling, every satellite needs to have a little engine or and a little bit of propulsion. Even though you're in a vacuum, you still need some propulsion to move around. Now, the amount of propellant that you need to have inside those satellites will depend on how many moves you want to make and what kind of orbits do you need to achieve, and also how long do you want that satellite to stay in orbit, right? So also take into account the bigger the satellite, the more orbit corrections you're going to need. So the thing is, that propellant will depend on the engine that you have. So it might be a mix of oxygen, nitrogen, other kind of chemicals. Honestly, I'm not an aerospace engineer, so I cannot really detail exactly what are all the propellants that are being used. But some are cheaper than others, and some are easier to store within the satellite than others. And also the engines, the kind of technology that you use in the engine also correlates with the amount of propellant that you use to correct the orbit. Also keep in mind that satellites slowly start going back down to Earth. Now, so you need to reposition those satellites eventually. So if whatever propellant you have, let's say the life of a satellite depends, among other factors, depends on this stuff. So some of the satellites end up having no more propellant, which means that they cannot correct the orbit. So eventually they will come back down to Earth. So if you can do refueling of that tiny propellant that the satellites have in space, then you can extend the life of a lot of these things instead of having to relaunch new things all the time. Now, the question is, do you want to keep them in space with lagging technology, or you would rather have it decommissioned and then fly up a new, cheaper and more advanced system? That's why the in-space servicing also means upgrading satellites. So there's a couple of companies also working on doing upgrades of satellites in space. So I can augment what the satellite can do instead of throwing it back into Earth and having to create a new satellite from scratch. So anyway, I believe we have, oh, there's one last one. Would it be possible to fuel these engines by solar panels? Yes, you can. Definitely you can. And that's how a lot of these systems get the power. But to a certain degree, as I said before, because you're going in orbit, sometimes you don't have enough energy. Also, keep in mind that the amount of energy that you need for that propellant depends also on the size of the solar panels, right? And because this satellites are becoming smaller and smaller, they can pack a smaller solar panels around the cube, right? Around the CubeSats, for example. So, okay, that was my son. So that means that the amount of power you can generate with those small satellites, it's very, very limited, which means that you cannot really create a lot of stuff with that. So you still need propellant in some cases to achieve what you're looking for. Okay, okie dokie. So I believe we cover most of the questions. We have a last poll, I believe, Sheena, with all the stuff we talked about, which we kind of extended a little bit here, but I hope it was insightful and at least give you more of a framework to start thinking about space. as I say, I'm personally excited about this, even though I'm not an aerospace engineer, but I'm a computer engineer, and I find this amazing. And the fact that it's doable now, it's incredible. So anyway, guys, last poll on what sector you think is most interesting. Well, maybe for you personally or in the future. Up to you. How do you want to answer this one? And anyway, I hope this was interesting for everyone. Thank you very much to everyone for tuning in. Let me actually, I had here under on the last slide, you have the slide share. So I'll repeat, slideshare.net/the Aleph. You have the slide deck there. If you want to download it, you should be able to download it. You have my email also if you want to contact. And Sheena also have my contacts. Sheena, the floor is yours, and thank you very much for everyone that stayed with us and tuned for this webinar. I appreciate, and I hope you enjoyed it.
Thank you, Alex. It's very, very, very clear how passionate you are about the topic, and we talked for an extra half an hour, and everybody stayed. So I'm really pleased that you did, and everybody who's connected, thank you so much for your questions. These sessions don't make any sense if you don't want to hear about the topic, and if you are not interested, it makes no sense for us to hold them. So thank you for being connected. Alex, we know how busy you are, and we know that this is time away, especially for your family. So it was nice to hear your son, but thank you so much for your time. And everyone, we are going to end the poll. I'm going to share the results so you can comment one final comment, but I will ask everybody to please fill out the survey at the end and tell us if you'd like to hear a follow-up part from this session, if you would like to hit certain areas or a topic that's not related to space tech. So let us know and we'll do what we can.
Yeah, it's interesting that space manufacturing is the second one. I mean, satellite image analytics makes sense, but wow, space manufacturing, that's very interesting. I think it's very interesting, that space, to be honest, and we're going to see a lot of stuff coming from that in the next few years. It's amazing that everyone stayed, and I have so much information on each and single of these points. So if you do definitely want to go deeper into some of these things, we can make an extra session to go deeper.
Great. Well, thank you so much. Thank you for your comments that are coming through right now. We will be recording the session with everybody who attended. If you have questions, all of you will have had an email from me, and we will follow up with Alex's LinkedIn details, and you've got the slide share, the deck of the slides on the chat. We will put them in the email too. Great. Well, thank you so much, Alex.
Thank you very much, everyone, and hope to talk to everyone soon. Thank you. Have a great day.
Bye. Thank
Bye.
you too. Bye.